Okay, so today we're going to look at solving a system of equations by graphing. This is the first method that we use for solving systems of equations. Just to refresh, a systems of equations is a group of two or more equations graphed on the same coordinate plane. Their solution would be the point where they intersect. So looking at the first equation here, 2x plus 3y equals negative 12. In order to graph this, I need to have y by itself, or get y equals. My first step here is to subtract 2x on both sides, leaving me with 3y equals negative 2x minus 12. My last step to get y by itself is to divide everything by 3, leaving me with y equals negative 2 over 3x minus 4. I'm just going to box this here. I'm going to go ahead and graph this. I'm going to start at my y-intercept of negative 4, and in order to get to my next point, I'm going to use my slope. In this case, I would have went down 2 and to the right 3, but I can't do that on this graph here, so I'm actually going to go up 2 and to the left 3. Again, I can't go up and to the left anymore, so I'm going to have my line here. I'm going to label it with the original 2x plus 3y equals negative 12. For the second equation, I'm just going to change the color. Let's go with blue. I have 5x minus 3y equals negative 9. Again, I want to get y by itself, so I'm going to subtract 5x from both sides. Negative 3y equals negative 5x minus 9, and then divide by negative 3. Y equals positive 5 over 3x plus 3. So I'm going to go ahead and graph that. I could always take my graphing calculator and plug this in into y equals, press graph to see a picture of it, second graph to see the table. So I start my y-intercept here. Again, I'm supposed to go up 5 and to the right 3, but I can't do that, so I'm going to do the opposite. So I'm going to go down 5, 1, 2, 3, 4, 5, and to the left 3. Notice I get this point here. I can't go down and to the left anymore. So here is my line here. Okay, I'm just going to change colors one more time. Now the solution is the point where they intersect here. So my solution to this system here is negative 3, negative 2, again the point where they intersect, which is right there. Since these are intersecting lines, there would be one solution, and we stated that negative 3, negative 2 is the solution. So hopefully that helped, and thanks a lot, guys.